Alright, this is question 6 from CS61B, midterm 1 from spring 2020. So in this question is kind of like an extension off of homework 3, the reader portion of homework 3. So at the top right here we give you kind of like a basic summary of the reader classes. And if you remember for homework 3 we had to implement these methods in our TR reader. But we're, in this question, creating a new type of reader. It says create a new shift reader that extends this abstract reader class and shifts. So it shifts the characters read from another reader that is passed into shift reader constructor as for TR reader in the homework. Shift reader adds the functionality that it circular shifts each set of characters read from it by a certain number of positions before adding them to cbuff. So they get shifted and then they get added to cbuff. And another thing to note is that this shift is non-negative, so we know that it'll at least be 0. And then if the possible shift is by more than the number of characters read, for example, shifting 3 characters left by 5 is the same as shifting them left by 2. So for example, we have a couple examples here. We have a string reader that reads in A through I in the alphabet, and we have a shift value of 2, which means that everything we read, we shift left 2. And so notice the first line, we are reading into our cbuff of all x's at position index 1 of length 4, which means that we are changing these 4. And you can see that those are the values that get. But we read 4 from our string reader, so that is the string A, B, C, D. And then we want to circular shift this left by 2. So that can look something like this by 2. So that means like shifting over by 1 gives us B, C, D, A. And then shifting over by 2 gives us C, D, A, B. And then you can see that this C, D, A, B matches the C, D, A, B that we see in the cbuff. Next, we read into index 0 of length 3, which means that we are starting at index 0 and we're reading length 3. So this is what we're working with respect to the cbuff. The second time we read, we've already consumed A through D, and now we want to be reading E, F, and G. Shifting this left once would give us F, G, E, and then finally, the second time, so this is 1 shift, this is 2 shifts, we will get G, F, or E, F. And as we see, G, E, F is what we get right here. And finally, we are looking at 3 and index 3, so that is this one right here, and length of 3. So we want to be considering this length of 3. The problem with this one that differs from the last two is that we reached the end of our string reader. Our string reader only has 2 characters left, H and I. So in this case, we only want to add H and I and not 3. We only want to add 2 and not 3. So if we shift this over by 1, we have I and H, and then if we shift it over by 2, we have H and I. And one thing to note is that these two are the same, which means if our lame, or this is characters read, if our characters read is equal to our shift, we know that it'll like fully shift all the way around and come back to what it is before. So this is a key observation that we will need moving forward. Yeah, so now let's move to the code portion of this question. So we have a shift reader class. I'm going to start off with kind of the constructor. So we see that we get passed in a reader. So this is the reader that is going to be doing a reading, and this is the shift. So these are going to be instance variables for our shift reader class. And that's because every shift reader will have its own reader and its own shift value. So knowing that, we can create instance variables for our shift reader that would be private up here, reader, and this will be underscore src, and then this will be private int underscore shift. And whatever you name these instance variables doesn't really matter. We like to do by convention, the instance variables is just the underscore in front of on the character. And then here, we just want to be setting these equal to their respective values that get passed into the constructor. So we've done the first part. We know that we have to save reader and our shift into our shift reader as instance variables. Next, we see this public. We see two public methods that we need to implement. So by observation, and the first one is a lot shorter than the second one, and also if we recall homework 3 TR reader, one of the methods that we have to implement is much shorter than the other one. If we go back up to our reader class, we see that the two methods that are abstract that we must provide implementations for are up here. So this is the read, this is the close. And so we must provide implementations for these two methods with here. The first one with only one line or space inside the body, we will be putting our close in because we don't need to do all of this other stuff right here for our close. We just need to call the close of the reader that was passed in. So close has a method signature. It has a void return type, and we are closing. So the name is close. It doesn't take any argument, and we also have to remember that this needs to throw IO exception. And we can see that this method header matches exactly the one we see up here. Void close throws IO exception. And we get rid of the abstract because we are now providing implementation for it. And what we do in here is we just want to call the close of our reader that was passed in. Nice. So now we are almost done. Now it's just the bulk of this question. So if we did close for the first one, the second one is read. If we remind ourselves the signature of read, it takes in, it returns an int and takes in a character array, another int, and another int. So we just copy that down into our method signature. So it's public int read, and we take in a character buff for character array, and we call it cbuff. We take in a start. We take in a length, and then we also have to throw throws IO exception. Nice. So now that we have the method signature done, let's talk about how we're actually going to implement our read. So one thing to note is we give a temporary character buffer of length. So if you recall, above in our examples, length in this one is 4, so that corresponds to these 4 right here. The length here is 3, that corresponds to this 3, and this length here is 3, which technically we should have an empty space right here, but since we don't read as much, that we don't have anything in that space. And so when we are thinking about what we are doing, our temporary character buffer should be a place where we store len characters. And len characters are how many characters we are expected to read with the read function. So if you recall from homework 3, right, we have an int chars read. We need to call the read function of the reader that was passed in to first read it and then make any necessary shifts. So in this case, we want to be calling the reader, or the read of the reader that we are given. The difference here is we don't want to read directly into our cbuff because we still need to shift it. And so that's where the temporary character buff array comes in. We will pass in temporary. We start at 0, and we try to read length amount. So after this line, if we think about our first example of, what is it? Up here, we have sr.read cbuff 1.4. That means we have a temporary that points to a character array of 4 that currently contains A, B, C, and D. And this character array is exactly as we see at the top right here. So now that we have our temporary character array, we need to transform this into what the shifted looks like. So one thing to note is we know that if we shift this by 1, we get B, C, D, A. If we shift it by 2, we get C, D, A, B. If we shift it by 3, we get D, A, B, C. And if we shift it by 4, we are back with A, B, C, D. And so the key pattern to note is if we write the indices for each of these, this value right here, these shift numbers correspond to the indices of the first in each of the sequences. So if we shift by 1, the first letter in our sequence is the first index. That's what this is. If we shift by 2, this C is the second index. Shift by 3, this D is the third index. And then if we shift by 4, A is 0. And so if we shift by 5, we will see that this circular shifting is kind of like modular. We will notice that 5 brings us back to B, C, D, A, which means that 5 and 1 both must go to 1. What that means is that every 4 we are looping back around to 0. So this is 0. And so this will tell us that, okay, for this example, we want to have value, this first one in this column will be the index at shift or underscore shift modulus how long this is. And how long this is not necessarily the length that was passed in because if we recall this example, even though the length was 3, we only passed in 2. And so this observation of characters read, not necessarily length, is what we want to be looking at. So it's shift modulus, cars read. So this is a key number, and this number represents the first element in here, or the index in which we will start the new or copying over. So if we have read characters, so there's a chance that we may not even read characters. So if we have read characters, we want to start modifying our cbuff with those characters read. So this if is if cars read is greater than 0. Now we want to save our this value into a number that we can reference. So this will be int actual shift, and this is equal to underscore shift modulus character read. So now that we have this modular shift, we want to we have 2 array copies that will be copying the contents of our temporary array into our cbuff array. And so if we notice, we will see that if we group each of these groups of 4 into 2 groups based on their consecutive letters. So the first one would be B through D and then A. The next one would be C through D and then A and B, D by itself and then A, B, and C. And then finally we have like A, B, C, D and then like nothing. So we are grouping our characters based on their consecutive characters so that we can create 2 groups, so we can do each group in its own array copy. So for our array copy, just a refresher, it takes in 5 arguments. The first one is array copy takes in 5 arguments. The first one is the source array. The second one is the source index, so where you're starting. Third one is the destination array. Fourth one is the destination index. And the fifth one is the length that you are copying over. So keeping this in mind, we know for our array copy, we want to be copying from our source. And in this case, our source is our temporary array. So we can fill that in right here. So from our temporary array, what do we want to start copying over? Where in our temporary array do we want to start copying over? And this is kind of like the observation here. Like if our shift is 1, we want to start copying over the first one. If our shift is 2, we want to start copying over this one. And that we know is this actual shift that we have down here. So that would mean that actual shift goes here. This is where we're starting to copy from our temporary array. Then we want to choose our destination array. Our destination array is our cbuff, because we want to be writing from our temporary into our cbuff. The offset for our destination array, so if we go back up to our example, right, we have temp points to A, B, C, D, and then cbuff. Cbuff is 1, 2, 3, 4, 5, x, 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 x. We want to be writing in here, and our call, this point is our start for our cbuff. And so, knowing that we want to write starting at this start, our cbuff will go start, or have an offset of start. And finally, how many characters do we want to read? Well, in this example, we want to read 3 characters. So if we know that this length is 4, and our actual shift is 1, and we want 3, and then how can we go from these two numbers to 3? And then we can see that this is a subtraction. If we take our next example, so we have 4 red, our actual shift is 2, and we want this length to be 2. And we have 4 red, this length is 1 that we want, and our actual shift in this case is 3. So we'll notice that how many we read in this first group is equivalent to the number of characters we've read minus our actual shift. This is colors red minus actual shift. So now after this line, our cbuff, in our given example for the first line, will have x, cd, x, x, x. So we've added the first half. Now with our second array copy, we want to be adding the second half, this half. So again, we are copying from our temporary array. This time, we want to be copying the beginnings. So if we look here, we are starting at A, so this is and starting at A, which means we want to be copying starting from the beginning. So this is index 0. Our destination array is cbuff. And now in our cbuff, where do we want to start? Well, we want to start at this point. So we know start is this one. We know that this length is characters read minus actual shift. So knowing that start points at the C, this length is characters minus actual shift, we know that the index for this will be start plus this section. So that's what we put here. Start plus colors red minus actual shift. And then finally, how many characters are we reading over? We can notice that this is 1, this is 2, this is 3, and this is 1, 2, 3. And so by pattern matching, we will see that the number that we've actually read is actual shift. And this can be confirmed with if we have a array like this, and we've shifted over x. That means the last x values are the first x values from the original one. So if this was like A, B, C, D, E, F, and we're shifting 3, right? And then it is A, B, C. We've shifted these 3, and then we have D, E, F here. So we know that the final bit is how many we've actually shifted. And then finally, the number of characters read is the same as the number of characters read when we read using the saved reader. So this is just characters read. Similarly to like we did on the homework. Yeah, so that concludes question 6. Hopefully this explanation was very helpful for you.